Hi, so this video we're going to cover ring modulation. I know it's a strange choice for an effect to actually run through, but it's one of the most simplest to actually explain. Obviously, you got flanging and phasing, but they're a little more complicated, and I think there's a bit more stuff that has to be done to make them actually sound quite good and control them better. Whereas ring modulation is just literally so simple. You're basically taking the signal source and you're multiplying it by the output from an oscillator. So what we've got here is two amp mods, okay? And then we've also got two multiply modules. I could use either one or the other. And what I'm going to demonstrate here is actually using either or. It doesn't really matter, they're basically going to give you the same result. You can ignore the high cut for the moment. This oscillator could just be going straight into the mod there, into the mod there. Okay, so the first thing that I'm going to do is I'm going to output this ring mod, okay? Right. Okay, so I've got a guitar plugged in. Okay, so you can hear that. That's basically these multiply modules. Now instead, let's take it out of the amp mods. Okay, push that again. As you can hear, that's exactly the same. So whether you multiply or use the amp mod, it's not going to make any difference. So really don't let the input and the modulation input confuse you. The multiply module is taking in the input and it's multiplying it by the output from an oscillator. Okay, so that's what the amp mod's going to do. The reason why we'll use the amp mod is because it's got some other options like offsetting, mod limits and mod amount, etc. So we've got the oscillator here, and not all oscillators are made equal. We've got the LFO's low frequency oscillator. They function at 1/4. I think it's a sample rate, not the Nyquist. I can't remember now. It functions at that rate. So if you want to go for really fast oscillation, the LFO isn't going to give you that best effect. I got an Empress Sawyer, and I absolutely loved the ring mod. Now, I'm not really a massive ring mod fan, but when getting into sequencing certain types of effects, a ring mod can actually be quite fun, and there's some interesting timbres that you can get out of it. I went and I tried to match that exact same thing in the H9000 without actually searching through too many of the algorithms. I did find an algorithm that sounded pretty much the same, but I wanted to build it from scratch. So I went through all the oscillators. So you got the LFOs, these work at 1/4 of the sample rate. Then you got these H9000 oscillators. I tried using that and that didn't really give me the nice ring mod sound. So I guess when you go into higher rates, they're just not all created equally. But this oscillator was great. Now I could have been doing something wrong, but I don't think it should be that complicated really. So I'm taking this oscillator and that's going into the mod input. Now an oscillator is going to work from typically, -1 to +1. Okay, if you think about the 0 being the 0 crossing point, the waveform just goes up to 1, minus up to 1, -1, etc. Now on LFO2, you can actually set what you want the polarity to be. In this case, it's going to be bipolar. So if I open up the docs, you're going to see there that polarity. 0 for the range of 0 to 1, and 1 for the range of -1 to 1. So that's going to be bipolar is going to be 1, and then unipolar, just 0 to 1 is going to be 0. We won't get into all this just yet. So then we've got that oscillator, and I'm choosing the modulation frequency using this knob, and I've set it to a default of 250 cycles a second, the minimum being 0 and the maximum being 1000. Okay, and here you can choose the waveform, sine, triangle, square, etc. And then there's this high cut, which is controlling this. And then that's going into the amp modulator modulation signal, and we're not actually controlling anything else here. So let's push that up. So what we're going to do, as you can see here, we've pushed the ring mod algorithm over to emote, and this is basically just playing an open A string. Okay, now I'm going to turn this down and then you'll hear really what is an actual ring mod. It's really just a tremolo. And then obviously you got all these different waveform shapes that you can use. So this is triangle. So as I turn that up, I'll turn that up to 250. You hear that's quite dirty. With the sine wave, it's a lot smoother. And the next thing that we're going to do is we're going to discuss this network over here, and I'm going to do some examples of that. So essentially, it's a sample and hold from a noise waveform. And noise waveform basically goes all over the place. Okay, so we're doing a sample of that noise, which is an erratic waveform at any one point in time. So we're using the LFO to trigger a one-shot, and it's going to apply an impulse to the new sample input on the sample and hold. And at that point, when it receives that impulse, it is going to read the value, the current value of the actual noise waveform. So that's the same open string. Okay, now I'm going to increase the rate mod depth. Okay, so we are changing the rate mod depth, which is essentially a multiplier. So it's to say, well, think of if when we're at 0, we're actually multiplying it by 1. We're multiplying the ring mod value by 1. And when it's greater than that, we're multiplying the rate mod frequency by 1.28. Okay, and then, yeah, so it's going to be that, and then it's going to be reading whatever the actual sample and hold noise value is. And because the noise value goes to negative figures as well, that's how we can go up and down from that point. Okay? And then the sample and hold frequency, we can basically set that to, let's say, 5, and that's going to be 5 samples a second. So you can hear what happens when we do that just to a tremolo. So yeah, if you have any questions, fire them in the comments below.